Hey everyone, welcome back. I know a lot of you out there are digging into LLMs
Yeah,
and you're probably starting to see just how complex these things can get,
absolutely. Yeah,
especially when you start to think about the training process.
absolutely.
One of the things that I know I've come across a lot is this idea of vocabulary size.
Right.
And it's essentially, how many words the model knows. And
Exact.
so the bigger the vocabulary seems like, the better it can understand and generate text, right?
Yeah, generally, the bigger the vocabulary, the better the model can understand different concepts and generate more nuanced text. So, yeah, you're on the right track there.
Okay, cool.
Yeah.
But here's the catch, right?
There's always a catch.
Um, as we make those vocabularies bigger, we need more and more computer power.
Right. Yeah, think of it like you're trying to fit a whole library
Okay.
onto a tiny little flash drive.
Okay.
And eventually, you just run out of space.
Right. The memory monster strikes again.
Exactly.
And that's what we're going to be looking at today.
Yeah.
In this deep dive, we're looking at a new technique developed by Apple,
Uh-huh.
and it's called Cut Cross-Entropy, or CCE.
CCE, that's right.
And this is all about tackling that memory problem head on.
It really is. It's quite amazing, actually. If you look at the paper and you see figure 1A,
Okay.
you'll see that the way we normally calculate something called cross-entropy loss during training,
Yeah.
it eats up a massive chunk of memory.
Okay.
We're talking even more than the model's weights and activations.
Wait, hold on. Even more than the model itself.
Yeah, it can be that extreme. For some models like, let's say, Gemma 2,
Okay.
the log probabilities, just those alone, can take up an entire 80 GB H100 GPU.
Wow, that's insane.
It's crazy.
So if we want to train bigger and better models, we really need to find a way to slim down this memory hog.
We got to find a way to make it more efficient, yeah.
Yeah.
Absolutely.
That's where CCE comes in.
That's where CCE comes in. The researchers realized that during training, we really only need the log probability for the correct label. It's kind of like if you're taking a multiple choice test.
Okay, yeah.
You only really need to know why the right answer is right, not why all the wrong answers are wrong.
Right, okay.
So you don't need to deeply analyze every single option. You just focus on what matters.
So instead of calculating and storing this giant matrix of probabilities
Right.
for every single word in the vocabulary,
Exactly.
CCE avoids even creating it in the first place.
That's exactly it. It avoids materializing this massive data structure in the GPU memory altogether. It's almost like it has this super efficient filing system that pulls out the exact information you need right when you need it.
That's really smart.
It is.
I'm guessing there's some pretty clever tricks going on behind the scenes to make that happen.
Oh, yeah, absolutely. There are some cool things happening under the hood.
Okay.
One of the key things is what's called indexed matrix multiplication.
Okay.
Essentially, what CCE does is it uses those ground truth labels, so those correct answers we were talking about, to directly grab the information it needs without having to calculate the whole matrix.
Got it. So instead of searching through a massive library, like going through every single book,
Yeah.
it's like having an index that just tells you exactly where to find the information you need.
It's like having a super precise map to that one specific piece of information.
Okay, and that's got to save a ton of time and energy.
Definitely. It cuts out a lot of unnecessary computation.
All right, so that's one part of it. What else is going on?
So another really interesting technique they use is something called the linear log sum x trick.
Linear log sum x.
Oh,
I know it sounds a bit intimidating.
yeah, I'm getting flashbacks to high school calculus right now.
Don't worry, it's not as bad as it sounds.
Yeah.
Think of it this way.
Okay.
Imagine you have a giant pizza.
Okay.
It's way too big to eat all at once.
All right, I follow you.
CCE figures out a way to slice it up
Okay.
into these smaller, manageable pieces
Okay.
that your computer can process much faster.
This is like a divide and conquer kind of thing. Exactly. It's breaking down a complex problem into smaller parts.
Okay, that makes more sense. And then what else? Is there anything else that it does?
Yeah, so to make things even smoother, it does some really clever things like filtering out unnecessary gradients.
Okay.
Now, not all gradients are created equal, right?
Right.
Some are really important for learning, and others, they barely make a difference.
So it's like a Marie Kondoing the model's brain.
Like decluttering, getting rid of all that unnecessary stuff.
Right. And that's got to help with the efficiency, too.
It does. And then on top of that, it also rearranges the vocabulary for even faster processing.
Wow. Okay.
So there's a lot of optimization going on here.
So CCE sounds really great in theory.
It does, yeah.
But does it actually deliver?
Well, that's the million-dollar question.
Right. So if we take a look at table 1 from the paper.
Yeah, that's a good place to look.
Okay.
What you'll see is some pretty remarkable results.
Okay.
CCE's memory footprint is tiny compared to the standard way of doing things in PyTorch or even other methods like Liger kernels.
Wow. So it really is making a big difference in terms of memory usage.
Yeah, it's a significant improvement.
Okay, but memory isn't the only thing, right? It also has to be fast.
Absolutely. Speed is crucial.
Right, if it takes forever to train the model, then what's the point?
Exactly. You want efficiency across the board.
So how does CCE stack up in terms of speed?
It's actually really fast. When you compare the processing time to other techniques, CCE comes out on top consistently.
Really?
Yeah, that gradient filtering and vocabulary sorting, those things really pay off.
Okay, so we've got the memory savings.
Yeah.
And we've got the speed.
We do.
But what about accuracy? We don't want to sacrifice performance just to make things a bit more efficient, right?
You're absolutely right. Accuracy is paramount.
Yeah.
We don't want to cut corners there.
So does CCE cut corners?
Well, the good news is that CCE doesn't compromise on accuracy. The researchers, they tested it out with a bunch of popular models like Llama 3, 5, 3.5, Mini. Okay.
They trained them on the alpaca dataset, which is a pretty common benchmark.
Okay, so what happened? I'm on the edge of my seat here.
The training curves, basically identical to what you'd get with the usual methods.
No way.
Yeah, CCE delivers the same performance without all those memory headaches.
That's amazing.
You can actually see this very clearly in Figure 4 of the paper.
So it sounds like CCE is kind of a game changer if you're training LLMs.
It really does have the potential to change the game.
Potentially, you could work with much larger models without needing a supercomputer.
Exactly. It opens up a lot of possibilities for researchers and developers who might not have access to those massive computing resources.
So what kind of possibilities are we talking about here?
Well, imagine being able to train these massive models.
Right.
Like models with trillions of parameters.
Trillions.
Which is just mind-boggling.
Yeah, that is mind-boggling.
But the thing is, CCE, it's like it unlocks the door to that.
Because one of the biggest challenges with pipeline parallelism, this idea of having like a team of friends building a Lego model together, is that you got to balance the memory needs across all those different workers.
Right. You don't want one of them to be like completely bogged down.
Exactly. You don't want one guy struggling with this huge pile of bricks while everyone else is sitting there twiddling their thumbs.
Right.
So because CCE is so incredibly efficient with memory, it could really smooth out that whole process.
Okay.
It makes it much easier to train these truly massive, super complex models.
So it's like an efficiency booster for the whole process.
Yeah, it's like greasing the wheels, making everything run a lot smoother.
So it sounds like CCE is opening up all these possibilities for LLM development, right?
Absolutely. And that's not even all of it.
There's more.
There's more. The paper also suggests that we could potentially squeeze even more performance out of CCE.
Oh, wow.
By implementing it directly in CUDA.
Okay, now what is CUDA? I've heard that term before, but...
So CUDA is basically this platform, right? That lets us tap into the immense parallel processing power of GPUs, which are graphics processing units.
Okay, so it's like using the power of your graphics card to make things even faster.
Exactly. It's harnessing all that raw power for AI computations.
So we're talking about making something that's already really efficient.
Yeah.
Even more efficient.
Even more efficient. It's pretty exciting stuff.
Yeah, that's pretty mind-blowing, honestly.
It is. It's really pushing the boundaries of what's possible.
But, beyond all the technical details and everything, I think it's important to kind of zoom out a little bit and think, okay, what does this actually mean?
Right, the big picture.
Yeah, like why should I care about CCE?
Right, why should anyone care? Good question.
Yeah, honestly, when I first started reading about this, it all sounded a bit, abstract.
Sure.
It's like, okay, cool, they made training more efficient.
Yeah.
But what does that actually mean for someone who's using these LLMs?
Right. What's the real world impact?
Yeah.
Well, for researchers and developers who are really on the cutting edge, working on the most advanced LLMs, CCE is like unlocking this treasure chest.
Okay.
It means they can finally build and experiment with these much larger, more powerful models.
Right.
Without being limited by, how much memory their computer has.
So we could be talking about really pushing the boundaries of what's possible with AI.
Absolutely, pushing the boundaries of language AI.
Okay, but what about for those of us who aren't building these models from scratch.
Right.
Does CCE have any impact on how we actually use these technologies?
Yeah, it definitely does. Think about smaller companies, maybe individual developers
Okay.
who might not have access to, the same massive computing resources.
Like Google and all the big companies?
Exactly, like the tech giants. CCE could really level the playing field here.
But,
It makes it possible to train and deploy powerful LLMs on much more modest hardware.
so it's like democratizing AI in a way.
That's a great way to put it. It's making these advanced technologies more accessible.
Okay, so instead of being limited to just, a select few,
Yeah.
it could potentially benefit a much wider range of people.
Absolutely. And that could have a ripple effect across so many different industries. I mean, imagine things like personalized education tools
Okay.
that are powered by LLMs and can adapt to each student's learning style.
Oh, that's cool.
Or healthcare applications that can help doctors diagnose and treat patients
Oh, wow.
more effectively.
Yeah, that would be incredible.
It's really exciting to think about the possibilities.
Yeah, so it sounds like CCE isn't just a technical advancement.
It's not.
It's really a potential catalyst for all these amazing innovations.
It's enabling us to build bigger, better, and more importantly, more accessible AI systems.
Yeah, I really like that. But we also have to remember that CCE is just one piece of the puzzle.
Right. It's one step in a much larger journey.
Yeah, this field of LLM training, it's constantly evolving.
It's a fast-moving field, for sure.
Yeah, there are always new architectures, new techniques, new hardware solutions emerging.
Always something new on the horizon.
So it's really a collaborative effort, right?
It is.
With researchers and developers all over the world just pushing the boundaries.
Pushing the limits of what's possible.
And it's exciting to kind of be a part of this and see where it goes.
Absolutely. It's an exciting time to be involved in AI.
Yeah, for sure. But as we continue to, develop these really powerful technologies,
Yeah.
I think it's crucial to keep the bigger picture in mind.
Absolutely. We can't lose sight of the bigger picture.
It's not just about making LLMs more efficient.
Right.
It's about making AI more beneficial for everyone.
It's about making AI work for humanity.
Yeah, exactly.
Okay.
We have a responsibility to make sure that these technologies are developed and used ethically,
That's crucial.
with a focus on their impact on society.
Yeah, we need to think about the social implications as well.
So we need to be mindful of potential biases, and make sure that things are fair and transparent.
Fairness, transparency, those are key considerations.
Yeah, absolutely. This has been such an interesting deep dive.
It has.
And honestly, I feel like we've barely scratched the surface of what CCE can really do.
There's so much more to explore.
What's really got you thinking after, diving into all this research?
Well, one thing that really stands out to me is this idea that CCE could be the key to unlocking these truly massive LLMs.
Okay.
Like models with trillions of parameters.
Yeah, we were talking about that earlier.
Yeah.
It's insane to even think about.
It's mind-boggling, right?
Yeah.
Just a few years ago,
Yeah.
models with billions of parameters were groundbreaking, and now we're talking about trillions.
Yeah, it's crazy how fast things are moving.
It really is a testament to the incredible pace of innovation in this field.
Yeah.
And CCE is like removing one of the biggest roadblocks to scaling up even further.
Okay, so it's like we've unlocked this whole new level.
Exactly. It's a whole new frontier.
But I have to ask, is there a point where a model just gets too big?
That's a good question.
Like, are there diminishing returns as we just keep adding more parameters?
It's a valid concern. While simply increasing the size doesn't always guarantee better performance,
Right.
there's a strong case to be made for the potential benefits of these massive models.
Okay, like what kind of benefits?
Well, imagine LLMs that can understand and generate human-like text
Okay.
with even greater fluency and coherence.
Right.
LLMs that can translate languages seamlessly, capturing not just the literal meaning,
Okay.
but also those subtle nuances and cultural idioms.
It's like we're blurring the lines between human and machine communication.
Exactly. And then think about the potential for creative applications.
Okay.
LLMs that can compose music, write poetry,
Wow.
generate entire novels that could rival the works of human authors.
It's both exciting and a little bit daunting at the same time, honestly.
I understand that.
Yeah, makes you wonder about the role of human creativity
Yeah.
in a world where AI can generate such sophisticated content.
It's a question we need to grapple with.
Right.
But ultimately, I believe that AI should augment human creativity, not replace it.
Okay.
We can use these powerful tools to enhance our own abilities,
Right.
to explore new frontiers of artistic expression,
Yeah.
and to create experiences that were previously unimaginable.
So it's more like a collaboration.
Exactly, a partnership between human ingenuity and artificial intelligence,
I like that.
working together to achieve something truly remarkable.
So it's not AI versus humans, it's AI and humans
Precisely.
working together.
Side by side.
I like that. And who knows what the future holds, right?
Yeah.
Maybe one day we'll be having this conversation
Wow.
with an LLM as a third participant.
That would be a fascinating deep dive.
That would be a very meta deep dive.
It would.
But for now, I think we've reached the end of our journey today.
I think so too.
This has been such an amazing exploration of CCE
It has.
and the future of LLMs.
A glimpse into what might be possible.
And I hope everyone out there listening has enjoyed it as much as we have.
I hope so too.
It's been an absolute pleasure diving into this with you.
Likewise, the pleasure was all mine.
And for everyone listening out there, remember, the learning and discovery never stops, right?
Never stop exploring.
So keep asking those questions, keep pushing the boundaries,
Keep that curiosity alive.
and keep exploring this fascinating world of AI.
It's a world full of wonder and possibilities.
Couldn't have said it better myself. Thanks for joining us on this deep dive. We'll see you next time.
See you later.